Hello, welcome to another briefing. So in this briefing, I'm starting out per usual with the satellite. We're going to take a look here and we're going to see, first thing I'm noticing is this big patch of clear skies over Northern California, the northern coast here. There's some small patches of marine stratus clouds in the far northern part of California. A little bit in what looks like slightly inland Mendocino County. And then there's some stratus making a little push into the Bay Area. Most of the Bay Area does have stratus this morning, although it's a pretty shallow layer. And there are areas of the north coast that are clear at the moment. Northern Bay Area coast, Sonoma coast, Marin coast. And then you do have some stratus down to Southern California. This is a pretty shallow layer in general. And I want to show you something on the close-up here from the Bay Area. You can just clearly see where we had a lot of north wind yesterday, and we still have some north to northwest wind. Based on this image here, you can see where that stratus deck is being sort of eaten away at by these north winds that they downslope down these mountains here, and they wipe out that marine influence. And moving on here, we have the I'm going to try to show the reason for this winds. For these winds, I know this is a bit technical on this map, but I'm going to try to simplify it, try to do a good job of explaining here. This is what was going on around 5 p.m. yesterday. Notice this little ripple here. This little ripple in the jet stream. These are basically constant pressure lines at 18,000 feet. And have this little, whenever you see like a little dip here, that's what we call a shortwave trough. And when we get one of those, you usually get a surface high pressure building on the backside of it. And that causes the winds here in the Bay Area to shift more northwest to slightly north at times, even down to the surface. And when that happens, we have that pattern where the fog gets sort of wiped out, at least during the day. And you sometimes have sloping warming down the hills here. And a lot of times in a lot of areas like South Marin, where I'm located, for example, you get what we call sea breeze shadowing, or what I call sea breeze shadowing. And I'm going to try to show that here. This is the map for high temperatures, observed high temperatures yesterday in the Bay Area from the National Weather Service. Weather Hazards Data Viewer, it's a great tool for checking this kind of stuff. And you can see here, look at these 80s all the way down to Mill Valley. I mean, my place in North Sausalito is 82, right in range with these readings from nearby. I mean, you see 80 degrees of the panoramic highway in Mill Valley. That this area usually, even in the summer, it'll stay in the 60s because you're getting that constant onshore wind. Definitely not the case yesterday. And so, in a typical pattern here, you would have the sea breeze coming through these little gaps here. There are gaps in between the mountains, and the sea breeze makes it through. And then you have the Golden Gate, of course, where it pushes through. And then it can come in this way, and it can come in this way. Yesterday, the wind, it was a little more, instead of the westerly, southwesterly wind here, it was a northwesterly wind. Now, if you get northwest wind, notice it's crossing these gaps at a parallel angle here. It's not blowing through these gaps. So it actually does still make it to the Golden Gate, and it does still make it into parts of the city and parts of the coastal East Bay here. And you can see, city was much cooler. 63 for Chrissy Field, 73 for Potrero Hill. Even the warmer areas in the city were around 70 yesterday, because you did get a little influence from that onshore wind, was able to funnel through areas in the city because those areas are exposed to the northwest wind. Here in South Marin, that's a different case. We get blocked, we get shadowed by these hills to the west of us here. And that causes warming. Sea breeze is blowing parallel here. It can't really penetrate. It can penetrate here and here, but this area is sort of cut off. And when that happens, you get warming. You get sort of a sea breeze shadowing effect, and that causes warming in this area over here. And that's exactly what happened yesterday. So if you can see the big picture. It's this little trough moving to the north. Whenever you have a little shortwave trough like this, and it's moving to our northeast, you have usually north winds on the back end of it, and you have that kind of scenario where the marine layer gets wiped out, and depending where you are in the Bay Area, you might get sea breeze shadowing, which means you warm up quite a bit even if you're at the coast or near the coast. Let's go ahead and look at the Mount Tamalpais camera from this morning. Now this is an interesting shot. As you see the shallow layer of marine stratus clouds, quite shallower than usual. So you can actually see like the Marin headlands, for instance, over here. These are usually socked in the typical marine layer, which is usually well over, or at least a bit over 1,000 feet, maybe 1,500. This is more like a 1,000-foot marine layer, if even that. Let me take a quick look here. Yeah, it's about 1,000 feet, because you can't actually, no. You can see just barely where I'm pointing here with the little white cursor. That's the tip of the tower of the Golden Gate Bridge, and that's at 700 feet, the top of that tower. So this is more like a 700 to 800 foot marine layer at this location, this part of the bay. And that's pretty shallow. So that's not going to make a far push inland, and when that mixes out, if the winds aren't too strong, that mixes out pretty quickly in the morning. Then you warm up quite a bit even near the coast. So I'm gonna take a look and show briefly the sounding. This is another complex meteorological tool that we use often. I know it's a little confusing for most people, but it's very useful for just getting kind of a picture of the vertical slice of the atmosphere. And the reason I'm showing it this morning is you can clearly see here where the inversion is. Now for reference, some of these have altitude on them, some of them don't. This is a pressure in millibars, but just to make it a little easier, I'm going to draw this arrow here. This is roughly where the 3,000 foot level is. So you just take the surface at the very bottom here, and this 3,000 feet here, you're looking at a marine inversion about halfway up. So that's about 1,500 feet. And you're seeing this temperature line in red. See how it's cooler down in this layer, and it even goes and it meets with the dew point. That's saturated air. That's the fog layer. Then you go right above that, up to 2,500 to 3,000 feet, and it's warm. You're having temperature quite warm, over 20 Celsius at this point. That's around 70 Fahrenheit. And compared to the surface, which is 12 Celsius, 54 Fahrenheit. Very warm and quite dry. You can see the dew point is lower as well. And then you have this tremendous distance in between the temperature and the dew point. That means the air is very dry. If you look at this part here compared to here where it's saturated. So that shows you there's that 1,000 foot, maybe 1,500 foot marine layer. You can actually get a more precise. Feel free to leave if you want, because I'm just getting very technical, but could get a precise precise piece of data for that. Huh. Wow, this website for some reason is not showing me the data for Oakland that I wanted to see. Maybe I can do it this way. Because I just want to see that text list. Because it tells you the exact altitude. And this isn't, of course, not going to work for me right now. Great. So much for that. But I hope it does give you an idea just looking at the sounding. Hopefully you're able to get an idea what I'm talking about with that shallow marine layer. Now let's go ahead and look into the future a bit and take it with a grain of salt. This is just model guidance. But you can see here the projection at the 18,000 foot level for that little short wave to push off. That's going to resume a westerly flow. I think at some point today into tomorrow we'll start to see a little more stratus at the coast because of that westerly flow. And then we could actually turn quite chilly with this next trough coming in. This is a much deeper trough. And as the trough passes, we'll have the wind speed up, likely out of the northwest, west-northwest maybe. And that'll probably deepen the marine layer. That'll bring more low clouds to the coast and such. And we'll have kind of that chilly pattern for at least the early part of next week. And then by late next week, maybe we start to see something where we're in the back end of this trough and we have a ridge building in. That could bring us a north flow again. That could warm things up. Now this is a projection all the way till next Friday, the 12th. So take it with a grain of salt. We're looking 8 days out. But something to watch that could happen. For now, the main thing to watch is going to be this gradual cooling, a return to an onshore wind, more marine clouds, especially in the morning. And then we're going to have kind of this cold snap here as we go into early next week. Probably lots of marine clouds, wind, maybe even a little chance of rain as we go into early next week. If this thing pushes far south enough and it links up with enough moisture, we'll have to keep an eye on that. That could be an interesting setup. So that's all I have for today. Actually, I'll go ahead and show the projected high temperatures for the Bay Area real quick, just to, so I at least touched on that a little bit. So here's for today. You can see still pretty warm most areas. SFO 68, Half Moon Bay 61. If you're at the coast or if you're slightly inland, you're going to be a little bit cooler, even with that northwest flow I was talking about. I mean, if you go all the way to Sacramento, you're 95 degrees. And then if you look at tomorrow, still pretty warm. I mean, I think the media coast will be cooler because I think we'll have more of an onshore flow. But yeah, decently warm still for most areas in the Bay Area here. And then you're looking at Saturday, there's that mega cool down that starts with that trough coming in. This will probably be stronger onshore winds, more of that deep marine layer with a stronger push here of onshore wind, and you can see that that cools off most of the Bay Area pretty nicely here. I mean, look at somewhere like Livermore, 91 on Friday to 75 on Saturday. That's a big cool down. Sacramento, 97 potentially Friday to 87 on Saturday. That's a pretty significant cool down for them too. And then you go here Sunday, Monday, you see much cooler conditions here in the Bay Area. As we go through next week, maybe heating up again. We'll have to see, take it with a grain of salt at this point. And that's all I have for today. Thank you for watching if you stayed this long. And I hope you got something out of this, and I'll see you next time.